Hello, guys. Welcome to the 12th episode of Introduction to Machine Learning in the Data Science Mentor Program. Now, there was a little error and in our last session, and I called that as last session number 10, but it was actually number 11, and we talk about grid search. And so that was the 11th episode. So in case you're watching this and you're thinking, oh, that was 10, but we're now in 12. There was a little error, and apologies for that. Right, so the Data Science Mentor Program is helping. It's a cohort dedicated to helping people learn data science from scratch, using mentorship as a service and examples for people to pick up the intuitions behind data science. Today, we are looking at a machine learning technique called feature engineering. And now, feature engineering is it's a technique that makes it easy. It's a fundamental idea of machine learning that helps us tackle the problem of data types. With machine learning in practice, right? You are taking your model has to understand the feature you're using, and sometimes you have to represent that feature in a different way. So we're going to talk about that today, right? Guys, my name is Pablo. I am a data science professional, founder of the Data Science Mentor Program. Right, and if you are watching this, if you're live in the session, then that means you're a part of the Data Science Mentor cohort. And if you're watching the recorded session, that means you weren't in the live session, so you have access to the recorded session. And sometimes we have our sessions streamed live. So if you're fortunate to jump on this, you're watching the live session or the live session, feel free to drop a question in the comment section. If you're interested in the mentorship that comes with the Data Science Mentor, and drop a message or drop a comment in the comment section. All right, so we're going to talk about feature engineering and why feature engineering is such a critical aspect. Now, but before we start, we have to look at the technical explanation of feature engineering and how it connects to machine learning. Now, we have to understand that machine learning is the technique that makes for competitive edge. Now, if you're a business person, knowing the future is a competitive edge. At first, you want to extract information from existing data, and that's the data analysis side of things. Now, the next step is you want to look at the data you have and try to predict what may happen in future with your business. It's a business application. It's super important. However, there are little techniques inside the main technique, or little tasks or sub-tasks or sub-techniques that helps the bigger picture. And so today we're looking at feature engineering. Now, I'll start off by sharing a technical definition of feature engineering, because at this point it's important to have the technical definition. Then we will jump over to a non-technical definition and explanation. Now, so okay, let me give this call this a technical definition. Now, every time you hear a definition, every time you hear about definitions that are technical, it would always start off like it is a process of. So the technical definition of feature engineering is basically the process of transforming and selecting input variables. See, big English. So that your learning algorithm can capture the underlying signal effectively the underlying pattern for making these predictions. You see that? See how technical stuff is? So here is the process of creating transforming and selecting inputs. Or input variables. Now, these input variables are also known as features. If I was to take a data, a regular data to explain this, is going to be interesting. So what I'm going to do here is I am going to use, let me see, do I have SNS in here? Yes, SNS dots. Let me use a data point. Okay, let me use Titanic data. I call this Titanic underscore data. And here I use from this Seaborn's data repository. Load underscore data set, and then I put Titanic. Now, for folks who are seeing this for the first time, you can load up a data from a data repository. It's stored there. You can pick it up. Then Titanic data dot head. So let's just see the first two columns here. So this is the data. Now, the Titanic data set has been used in many ways to explain machine learning techniques in very introspective or very intuitive ways. Now, the Titanic data set has this column called survive. Now, the idea is simple. By checking out each feature, can you build a model that can predict if the folks who were on the Titanic survived or not? So the reason why I brought this up is so I can make this very intuitive definition, but this is still our technical definition. So let me go back here and say the process of creating, transforming, and selecting input variables, which are these guys you see over here, these guys, right? So the reason you do that, it's so that a learning algorithm can capture the underlying signal. Now, this is a technical definition. So what it means is you want to figure out, if you have to predict whether people survived, then you have to transform some of these features so that the algorithm can understand what's going on, right? So that is a technical definition. Now let us head to a non-technical definition. So here I am going to call this the non-technical definition. Now, here with non-technical distributions, we now use real-life situation. Now, the context is this, and for every context, we're going to make it a definition. So, feature engineering it's like cooking. It's like cooking. That's what it's like. That's the first part of it. Now, before you cook, right, you have to prepare your ingredients. So before cooking, you have to prepare. You have to prepare your ingredients. What am I saying? The ingredients. Right. Now, what are we doing? We're cooking what? Now, while you're cooking, the first thing you want to have is you want to have the raw food. And the raw food is what? Your raw data. That's one. Now, remember that raw data is not tasty in itself, right? You typically have to do a bunch of things, right? So part of the cooking itself is washing. So these are the activities in cooking. So like call this the activities for cooking. Now the activities for cooking means you wash, you chop, you chop, you cut, you season, you combine, you do all these things, right? You do all these things. Oh, sorry, you combine. And part of the reason you're doing all these things is to bring out the flavor. Now, this, my friends, is feature engineering, because without feature engineering, bringing out the flavor, which is a huge part of it, right? Because you need to have good food, you need to eat really well, and that's basically what feature engineering is. If we go back to this technical definition here, you can see that part of these activities are all as you see here. And the ingredients are your features. Those are your features. And these are the columns you have, right? Your features, look at them. Your ingredients, right? And at the end of the day, this whole stuff you have here that you created here is the raw food, right? And the tasty part of it is what you're trying to predict. And this basically exists in every cycle of business, life endeavors, and if you have data, then you can make really great sense of it, right? So it's important that these things are done. Now, for you to get to, there's almost always a question: why? Right? Why does it matter? And so at every point, I'll share the technical reason why it matters. So the question here is, why does it matter? Why does it matter? Because why on earth do we have to do feature engineering? And again, like I always tell everybody, if you are doing all this, you can see that the important part is understanding the reasons why you do what you do. Before you get to the point of writing code, code is not the primary aspect of it. Writing code is as a result of the problem you're solving. So one of the reasons for feature engineering is called signal extraction. Yeah. Basically, what you're doing here is transforming raw fields or raw features. That's what you're doing, transforming raw fields. This is like your cutting, chopping, washing that you do when you're cooking stuff. Another thing you want to do is there's something called model compatibility. So it's called model compatibility. Now, because you need to do a prediction, you need to make a prediction, you need to be sure your features are compatible with the model you're building. You need to be sure your ingredients are the right proportions or are the perfect nature for that food to taste right. You know, there are ingredients you get, and to get the stuff out of them, you have to cut them. Some you have to wash them. Some you have to put them in water or stuff like that. Right? So for model compatibility, many algorithms expect numbers, scaled inputs, right? So it's typically like that, just like number scaled input. For some meals to taste really great, they expect, you know, certain kind of seasoning. They expect some mixture of seasonings, like you have to mix this and that and all, and they expect you to put them at different times, right? You do this because there's something called bias/variance control, and these are technical terms, but I'll, you know, now bias/variance control, when it comes to the cooking analogy, means you want to be sure the salt isn't too small or isn't too much. You want to be sure the meat was boiled to perfection, stuff like that. So you want to set it up. So in the machine learning technology, you want to reduce variance, which is called overfitting. Variance, and I've mentioned it in the past, in our past sessions. Variance is when your algorithm understands your data so much that it can tell what's coming next. It's like you know somebody so well, you can tell what they'll do next. But let me give a slight detour. It's like you've been in a relationship with someone for a bit, maybe for 2-3 years, and you understand them, and for some reason that person is gone, maybe the relationship broke down, and now you meet someone new, and you think you can predict their behavior from the person you've known. What you're doing is you're overfitting. It's what you're doing. You're overfitting because you think, oh, I know what you're going to do there, and the person says, I don't know what you're talking about. So that's basically what it is. So it's bias and variance control. When they say something is underfitting, is you cannot understand the model can't understand the data, so it doesn't know what the hell is going on. The perfect way is to after all the ingredients, your food tastes bland. So all you're trying to do, right, or all this, you're trying to ensure that your model knows what's going to do. So so these are technical stuff that you're trying to do at the time, and that's what we're trying to do when we do feature engineering. This is it. It's the feature engineering. Again, the cooking analogy comes first. Now, and so that's basically it. So there are other technical terms we're going to work with, but this is it. This is basically that. Now, what I'm going to do is I'm going to show some of these techniques, right? So that we can start to think about it in different ways. I'll give you an example. Here is a perfect example. So here is a technical example. At this point, technical examples are what we're going to use. So here is a technical example. Now, there's something called a categorical feature. At this point, I'm acting like you guys have never heard of it, but categorical features are, they are non-numerical data. So we're going to be looking at a categorical feature. So categorical feature. Yeah, so these non-numerical features. Now, a lot of the algorithms we're working with must, just like we mentioned here, right? Many algorithms expect numbers, scaled inputs. Let me put dot. There are other things there. Now, but sometimes when you're exploring your data, and your data happens to come in different ways, shape, or form. So let's look at the data we have here. Let me make this maybe 5, so you can see. No, what did I do? Oh, sorry. So let's look at this data. So let's say that in this data we take what are we going to take here? Say we look at, excuse me, we look at fair, right? So let's say we look at fair. So we're going to create, we call this data. Now this data is going to be in a list. And inside that list, we're going to create a dictionary. So the first thing inside here, we're going to call this fair. And fair means it has it's a certain price. So we'll call fair, and then let's take this guy. This is going to be our fair. We'll put it here. Then we'll put comma. Then the next thing we're going to come for here is we are going to look for something like it. Let's say age, right? So we'll put a comma here and say age. And in age, we say the first age we have here is 22. 22. Next, we come here and we say, okay, look at this, Embark Town. And we say Embark Town. Right? So when we come here, the next thing we'll have here is Embark Town. And Embark Town, one of the towns we have here is Southampton. Now, if you look at what we have done here, you will see some things are happening here. We now have, you can see that we now have fair, number, age, number, Embark Town, category. So what I'm going to do is I'm going to recreate this guy into, say, 4 ways. So we're going to do this. Oh, excuse me. Have a comma. Put this here. So now when we go to fair, we'll take this fair and replace some of the ones we have here. So fair here, we'll make changes. So this is how your data will typically come. Age here, we have 38. Now Embark Town here, we have Cherbourg. So let's do one more. So one more, maybe we'll do two more. Now, guys, mind you, all this, when you start learning all this, part of the introductions you'll have seen for folks who just started, you see, you have to learn data types in Python, which is, you have to learn variables. You see that what I have here is a variable. What I hear is a data structure and data types. So you see, it's why it's important while you're watching this new stuff, be patient. You're going to get to this point where you need them. So let's look at this. We have fair. Let us take this as fair. We'll come over here and we'll make this. We look at age. Age is 26. And embark town. Let's look at something else. There should be some more embark town. Let's even make this thing 10. We'll find new. We have Queenstown. Lovely. So let me make this again 5. Let me just make it 2 so we can now see what we're doing. So here we now change this to Queenstown. So now this is the data we have now. So just for some reason, you see that when it comes to embark town, you see that the data type is different from this guy. This guy is a numeric, is a float. They're different. Now, how do you do some form of conversion, right? Now, so in some thought processes, you might be tempted to say, let me encode them this way because that's only what makes sense, right? So you now say, if I encoded them this way and say, if we have Southampton, we would say that Southampton will be equals to 1. We say, oh, Southampton is equals to 1. Then Cherbourg will be equals to. And I want us to understand something. When we do it like this, the algorithm tends to act differently. Once we put this way, now it will turn out that what this is called is a straightforward mapping, right? Once you do stuff like this, there is a fundamental assumption that Cherbourg is greater than Southampton and that Queenstown is greater than Cherbourg. So that's generally the way the model will make its assumption because it will think so, but it makes no sense. You cannot just do it that way. So what you have to do, you have to introduce something called a technique called one-hot encoding. The one-hot encoding technique would let you, it will let you convert, right? It will let you effectively create columns indicating the presence and absence of these guys. That's what it is. So this, let me also write it here. This technique will effectively create columns representing each category, representing the presence and absence of each category. So that now at this point, there's no assumption that one is typically better than the other. And so that's typically what we are going to be talking about. And there are techniques for doing this, right? Now, generally, when you're learning data science or fundamental data science, you might be told, okay, use one technique over the other. But this is the reason why you would use a one-hot encoding. We'll talk about maybe using the dummy variables, but this is the reason why you will typically want to use a one-hot encoding. Now, to do this, right, you will take your list, sort of the list of dictionaries, and then there's something called dictionary vectorizer, right? You would vectorize it, and to do that, it's an ML technique. You will call the model class, say sklearn dot feature extraction, and then you import dict vectorizer. So this is what you use. Now, so what I'm going to call this, I'm going to now call this like a vectorizer. So I'm going to say, I'll call this vec for short. So I'll just say vec. So I'll say dict vectorizer, open, I say sparse. Let's just say for now, sparse is false because it's not much, right? And I'll say my D type, I want them to be integers, right? And I run this. So I've put this guy in here. Now I'm going to say vec dot fit the data that I have, the fit slash transform this data I have. So guys, remember this data here, this guy, this is what I'm going to transform. This data that if I come over here and I print bracket data, that it comes out like this. It tells me all this. I'm going to vectorize it right now. And then when I run this, see what happens? Now, can you guys notice what has changed? Can you guys, if I was to bring this guy down, you notice that we have 22, 38, and 22, 38, and 26, which is the age representation. We have 7.2, 71, 7. You can see over here, this has now been, you can see what it did. It basically turned them to this. But in here, we now have 3 columns. This column, yeah, 3 columns basically, just if we were to look at it like this. Now, these are the representations of Southampton, Sherborne, and Queenstown. For this first part where we have Southampton, it's telling us that in these 3 columns, 0 represents Sherborne, right? Yes, 0 represents Sherborne. 2, this 0 here also represents Queenstown, and 1 indicates the Southampton. And when you come to this place, it's going to tell you 1 indicates Sherborne, 0, 0. So that means at any point, an indication of 1 is the presence of a categorical feature. Now, this, my friends, is feature engineering in practice. See, now for some reason, right? It is intuitive to do it like this rather than saying, "Oh, I'm just going to, convert them to zeros and ones." Right? So that's basically one of the things you want to do. Now, just so you know, you want to ask yourself one final question. Is there any meaning to this, to all these features here? Really great question. Like, are there meanings to these zeros and one? It's a very powerful question. Are there meanings to these zeros and ones? Well, do you know how we're going to find out? We're going to find out by saying vec.get feature names. And if I run this, it will break these things down. So you see, it will tell you that there's this guy and there's Embarktown, Cherbourg, Embarktown, Queenstown, Embarktown, Southampton. So it knows that these features are in there. And so when the algorithm, right, when the algorithm starts to do stuff, starts to look through them, these algorithms could basically understand and say, we know what we are working on. So that's why when you're doing your feature engineering, the algorithm knows. It definitely knows what you're doing. Now, there is one disadvantage. Yeah, there's a disadvantage because of, we're using very small features. What if very data? If your data, one of the data is huge, and it has so many categories, then it will increase the size of your data set, right? So remember what we did the last time. Because it will increase the size of your data set, we're going to do something. If I was to take this here, see this vec here, right? I can, yeah, so here, let me write this. If we have so many categories, comma, what to do? It's a very cool question, what to do? Because it's a disadvantage, right? It's a disadvantage. If we have all this, a disadvantage. So one thing we could do is, if we bring this here, we can say sparse equals to true. And if we run it, right, and then we go ahead to fit our data, if you tell us, yes, your sparse matrix has this type with stored elements in compressed rows, right? And it will store it and compress them in a way if it's too much, right? So that's what it's going to do, right? So guys, this is just the first part to it. So what we have just spoken about is a way for us to do feature engineering. Look, if it's your first time watching this, some of this will just sound somehow to you. But I just want you to know that if you look at what we have been doing, you see a lot of the things we've written like code are just down to what you are learning from the very beginning. When you are learning, you're learning variables, data types, and all. So these are the things you're learning. Right, so that's that for today. If you're in the call, if you're in the live call, please feel free to ask any question. If you're going to be watching this session, the recorded session, then it means you have access to the recorded session. And then feel free to drop any questions in our Telegram channel, or you can send me a message. And if you're watching this live stream, then it's really gives you an opportunity to gives you out for you to get this going on, and for you to know, okay, this is such an important journey in your data science learning curve. All right.